All right, we have 2 minutes to go. If you have any questions, this is the time. Okay, any questions? Anything? Okay, it is 6 o'clock. I want to respect your time. Thank you so much for being here on time. I appreciate your dedication and commitment. Before we start, a couple of reminders. First, important dates. As this table shows, it is on your course outline. The next coming important due dates are February the 10th this Friday, February the 10th at 7 p.m., 1 hour and 15 minutes, our first midterm test, test 1. Okay. The location is TH247. Practice test questions is posted on Brightspace. There are 10 questions. Today we'll go over those 10 questions after the lecture, okay, for practice questions. Next important due date is February the 16th, written assignment 2. Okay. So those are the important upcoming due dates. Any questions? Please ask questions throughout the lecture. Stop me at any time for any questions, okay? I got a suggestion about doing more questions about implicit, differentiate implicitly. So I'll keep that request in mind. We do the lecture first, then we do some questions about implicit differentiation. After that, we'll do 10 questions review for test 1. You have those 10 questions on the Brightspace. Okay. Questions about the agenda for today? Okay. So today is our week 5. We are going to go over 2 sections, session 1 of chapter 4 and session 2 of chapter 4. Session 1 is about applications of first derivative. So look at this example here. It is a Department of Energy and Shell Development Company. This is the typical car's fuel economy as a function of its speed. The speed is measured in miles per hour. If your speed is between 0 and like 42 here, so when you increase speed, the miles per gallon here is in y-axis. Miles per gallon is also increased. But after reached at a point roughly 42, when you increase the speed, the miles per gallon decrease. Okay, miles per gallon decrease. So this is the relationship between the speed. Speed is x and miles per gallon. It is like the parabola, okay? Second degree of polynomial. Okay. From this example, we introduce a function is increasing. When a function is increasing, how do we know? In this diagram, the function from here to here increasing. The function from here to here decreasing. So increasing and decreasing. And how do we know the function is increasing generally? When you have, for example, 20 greater than 10, so what is the miles per gallon for 20? It's roughly maybe 25. The mile per gallon for x equal to 10, roughly equal to maybe 12. So 25 greater than 12. When you have x1 greater than x2, for example, you have y1 greater than y2. If this happened, the function is increasing. And how do I know the function is decreasing? Take example of 50 and 60. If 50 is your x1, 60 is your x2, just for example. So what is the y for when x equal to x1? The y is here. Maybe 33, okay, miles per gallon. And when x equal to 60, what is y? Maybe roughly, maybe 30. Okay, so this is y1, this is y2. When x2 greater than x1, when x2 greater than x1, you have y1 smaller than y2 smaller than y1. This is the typical situation when a function is decreasing. So this is the definition. When you have x1 smaller than x2, you have fx1 smaller than fx2. But when you have x1 smaller than x2, fx1 greater than fx2, this is decreasing. Okay. An example for increasing, if x1 is here, x2 is here. This part is increasing. This is decreasing, x1, x2. This part is decreasing. Any questions on increasing, decreasing? One simple way to remember decreasing, increasing, looking at the direction. When x1 smaller than x2, fx1 smaller than fx2, this is increasing. When x1 smaller than x2, fx1 greater, the change the sign, okay? This becomes greater when this is smaller. That is the decrease. Another way to say increasing, the same way, if x1 greater than fx2, when x1 greater than x2, this is increasing. You say greater, greater, they are increasing. And this one decreasing, I can also say when fx1 smaller than fx2, when x1 greater than x2, this is decreasing. This situation is increasing. So that is a decreasing and increasing. And the other way to say decreasing, increasing is to take the derivative. If the derivative is negative, like this picture here, derivative at the point C is negative. It is decreasing. And when a derivative in this picture, derivative greater than 0, it is increasing. So this is the relationship between derivative and increasing or decreasing. Just take a derivative. You know the function is increasing or decreasing. Any questions? Okay. So now, how do we know at which intervals the function is decreasing or increasing? So this is a theorem. This theorem, we just accept it as axiom without proof. If a derivative greater than 0 in interval AB, so f is inquiry on AB interval. If derivative smaller than 0 in interval AB, f is decreasing in AB. And how about if derivative equal to 0? When derivative is equal to 0 in interval AB, f is constant on AB. does not increase, does not decrease. It is a constant. Questions? Okay, example. Found interval where f(x) equal to x squared is increasing, and the interval when it is decreasing. We know the graph of x squared is this one, parabola. By graphical examination, we know when x greater than 0, y increasing. When x smaller than 0, y decreasing. This by examining the graph. And how do we solve this problem without looking at this graph? Okay, just looking at x squared. We use this definition. Find the derivative of x squared. So we know if f equal to x squared, derivative equal to 2x. This is because the general rule x raised to power n, derivative n times x raised to power n minus 1. So when derivative greater than 0, it is increasing. So we solve for this equation. 2x greater than 0, you get x greater than 0. And when derivative is smaller than 0, we get x smaller than 0. That's how we solve the increasing and decreasing algebraically without looking at the graph. We solve by find the derivative first. When derivative greater than 0, it is increasing. Derivative smaller than 0, it is decreasing. Any questions? All right. This one, we are going to take example to illustrate this part. So determine the intervals where function is increasing or decreasing. So first, find derivative of fx prime. Let derivative equal to 0. Those points, or sometimes if f prime means derivative is discontinuous, we identify those numbers. What numbers? Either derivative equal to 0 or derivative is discontinuous. So identify those numbers. And then we select a test number in each interval for, remember, if you have those numbers could be 2 numbers, or could be 1 number, 2 number, 3 number, 4 number, etc. Suppose those number is 1 number. If you just have 1 number such that the derivative equal to 0, and you use that number, divide the whole real number in 2 parts, just 2 parts, either this part or this part. And if you have 2 numbers such that the derivative equal to 0, that 2 number will divide the real number in 3 parts, 1, 2, 3. So those 2 numbers usually is the derivative equal to 0. And if you have 3 numbers, those 3 numbers will cut the real number into 4 parts, 1, 2, 3, 4, not necessarily equal parts, okay? So 1, 2, 3, 4, 5. You have 5 intervals, okay? This is step 1. And in step 2, you select a test number in each interval. This is an interval when you have x just 1x. And this is interval, interval, interval when you have 2x, x1, x2. And this when you have 3x. Okay, this is actually when you have 4x. I should draw another picture. When you have 3x, you have those intervals. You found a test number in step 1, then determine the sign. If f prime c greater than 0, f is increasing. If the derivative smaller than 0, f is decreasing. This slide looks like abstract, not intuitive, but when we go example, it will help you understand this part. Okay. So now let's do the example. This graph gives the U.S. budget surplus or deficit from 1996 corresponding to t equal to 0. To 2008, t equal to 12. The relative maximum and the relative minimum of the function are indicated on the graph. So this graph has from t equal to 0 to t equal to 12. Okay. So this example, I will explain two concepts. One is relative maximum. The other is relative minimum. Relative means it is only consists of a small area, the area nearby. The area nearby. For example, this point is the relative maximum because this number is greater than all the number nearby. Nearby. But this number is smaller than, for example, the number here. The relative means you only consider nearby. So we said this is a relative maximum because it is greater than all the number here. All the number here. And similarly, this point we call relative minimum because this point is smaller than the number nearby. Okay. And the same thing for here, this point. This point is relative maximum because this number is greater than all the number nearby. And just from this diagram, this relative maximum is different from this point is also relative maximum. Did anyone spot the difference? There are two relative maximum, but they are different. Did you see the difference between those two maximum? Yes. Yes. So this maximum is above this maximum. Actually, the maximum here is the greatest number on all the curve. See, this is all the points on the curve. If you consider all the points on the curve, this number is greater than any point on the curve. Do you agree? So that relative maximum is actually absolute maximum. It is this point is greater than all the points on the curve. But this relative maximum is just maximum, maybe from here to here. It is greater than here. It is not greater than this point, this point. Did you see it? They're both relative maximum, but the fourth maximum is actually absolute maximum. This point greater than all the points. And this point is just greater than the point nearby. And similarly, if I give you, if this curve, suppose this curve continue this way, okay, continue. And this point is relative minimum. But this point is also relative minimum. The difference between these two relative minimum is that this minimum is smaller than all the points on the curve, this minimum. And this minimum is just smaller than the point nearby. Okay, so this minimum we also call absolute minimum. Okay? It is minimum for the whole point. So any questions on the relative minimum, relative maximum, absolute minimum, absolute maximum? So this is the definition. What is the relative maximum? If there exists an interval AB and C is inside AB, so this is AB, C is somewhere inside AB, such that when fx smaller or equal to C for all x in AB. So at this point, FC is the relative maximum. FC is relative maximum because all the points within AB smaller than C, FC. Questions? In this graph, let's examine the relative maximum. How many relative maximum for this graph? We found one. This point is a relative maximum because it is greater than all the points nearby. This point is a relative maximum because this point is greater than the point nearby. So those are relative maximum. Can you identify which are the relative minimum? Yes.
X2, X4.
Perfect. X2, X4 are relative minimum because this point is smaller than nearby. And at X4 smaller than the point nearby. Okay. And can you identify, if I erase everything, which point is the absolute maximum, which point is the absolute minimum? Means use common sense, which one is the maximum, which one is the minimum? That is the absolute maximum, absolute minimum. Which one is the absolute maximum? It is actually this point. If the graph ends here, this is absolute maximum, right? Which one is absolute minimum? Looks like this one here. This is the smallest point. This is the maximum point. Okay. Right. And this is what is relative minimum. If you have open space, if you have AB, this is A, this is B. If you have a point C here, such that Fx greater or equal to Fc. So if Fc is the relative minimum, Fc is relative minimum. Now, how do we find the relative minimum and relative maximum? we take the derivative. If derivative greater than 1, change it to derivative smaller than 1, and we know this one is a relative maximum. If we found the function increasing and then decreasing, this point must be relative maximum, from increasing to decreasing. On the other hand, if we found a function is decreasing, then increasing, and this point must be relative minimum. So derivative change from negative to positive. From negative to positive, it is minimum. Okay, new concept, critical number. It is a number such that derivative equal to 0 or derivative does not exist. Those numbers are called critical number. For example, if I have fx equal to x minus 2 times x minus 3, I ask you to find the critical number. The question asks you to find the critical numbers. So to find the critical numbers, we have to find the derivative first. So what is the derivative of this this function? To find the derivative, you can have two methods for this function. Method 1, you expand the expression to x times x minus 3 minus 2 times x minus 3. And you get, this is not derivative, this is just simplify the original expression, fx. First, we simplify original expression, and it becomes x squared minus 3x minus 2x plus 6. So simplify x squared minus 5x plus 6. Okay, this is method 1. Simplify original expression, then find the derivative. Find the derivative of this quadratic expression. So you got 2x minus 5. And now let derivative equal to 0. And you get x equal to 5 over 2. And this number is a critical number. So definition of critical number, derivative equal to 0. Those x are critical numbers. This is just method 1. Method 2, use product rule for derivative of this expression. Method 2, product rule. Product rule said f times g, derivative, this is times, equal to ft prime plus gf prime. This is the product rule. And then you use this product rule, found f prime x equal to f is x minus 2, g prime, g is x minus 3, plus g, f prime, directly apply product rule. X minus 2 times x minus 3 prime equal to 1 times 1 and plus x minus 3 times x minus 2 prime 1 and equal to x minus 2 plus x minus 3 equal to 2x minus 5. In order to find a critical number, let derivative equal to 0 and solve for x. The same result as we get using the first method. Any questions? Find the critical number. We'll take example to illustrate this theoretical procedure. How to find the relative maximum? How to find the relative minimum? So to find the relative maximum or relative minimum, first we need to find critical numbers. And then we examine f prime x. If it changes from positive to negative, we conclude it has maximum, relative maximum. If f prime derivative of x, fx, change from negative to positive, it has relative minimum. If derivative does not change, it does not have maximum or minimum. Any questions? Let's take a look at the example. Find the relative maxima and the relative minima for fx equal to x squared. So how do we find? First, we need to take a derivative of fx. It is 2x. Derivative of x squared is 2x. And then we let derivative equal to 0. We get x equal to 0. And once we get this 0, so what? We know 0 is a critical number. 0 is a critical number. And then remember this real number, we divide in two parts. This is 0. One is smaller than 0, the other is greater than 0. We examine the derivative of f prime x. So when x is smaller than 0, the derivative smaller than 0 because the derivative is 2x. And when x greater than 0, the derivative greater than 0. And do you see the derivative change sign from smaller than 0 to positive to greater than 0? When derivative change from negative to positive, we know this function has a minimum based on this conclusion here. F prime changes sign from negative to positive. And we know it has minimum at x equal to c. In this example, c equal to 0. This example, c equal to 0. So this is a C point. At the point C, f has a minimum. Any questions? Minimum, the derivative change from negative to positive, then you have minimum. And this is the graph. This is derivative smaller than 0, this part, derivative greater than 0. At this point, derivative change from negative to positive. So this point is the relative minimum. Derivative change from negative to positive at the point 0. So we finished session 1 of chapter 4, applications of derivative. Important concept is relative minimum, relative maximum. How do I find relative minimum and relative maximum? Follow this procedure. First, determine the critical number, and then watch the sign of f prime x, the derivative. If the derivative changes from positive to negative, you have maximum. If derivative changes from negative to positive, you have a relative minimum. So that is session 1 of chapter 4. Any questions? Okay, session 2 of chapter 4. Determine the intervals of concavity. There are 2 graphs in this slide. One graph is showed the population of the world. Okay. World population in graph A. And in second graph, graph B, it showed United States population. As you can see, they both increase. Both world population and United States population increase, but they have different pattern. The world population is increased like this. The United States increase like this. They have different pattern. Okay, and we call this shape is concave up, and the second one is concave down. It is this one looks like this one, parabola, and this one looks like this one if you continue, parabola. And this one you can imagine is this one, this is this one. They both increase from here to here. This is increase, and from here to here increase, but they have different pattern. Okay. And the first we call concave up, the second concave down. When you have a concave up, you always in your mind connected with x squared, because x squared curve looks like this. And concave down, you connect with negative x squared. Negative x squared looks like this. And now, how do we determine the concavity? So, concavity of function f. What is concave up? If First derivative is increasing, it is concave up. How do we know the concave down? If first derivative is decreasing, it is concave down. The graph for concave up is like this. Graph for concave down is like this. Concave up, concave down. Any questions? And remember, this is not F increasing. This is F prime increasing. And this one is F prime decreasing, not F. Derivative increasing, derivative decreasing. Any questions? This is important, so I pause for a moment to see if you have any questions. All right. Okay, here another two graphs. We already did this actually. So this graph is concave up, graph A. Graph B is concave down, concave down. The reason for graph A is concave up because F prime derivative is increasing. How do you know derivative is increasing? You see the red line? The red line, okay, see those are the derivatives are increasing. Graph B, the derivative decreasing. From here, decreasing to here, and to here, to here. The derivative increasing, derivative decreasing. It is not F increasing, not F decreasing, not. It is derivative increasing, decreasing. Okay. Okay, now we use the second derivative. If second derivative is positive, the graph is concave up. So how do we know it is concave up? Find the second derivative. Second derivative greater than 0, concave up. If second derivative smaller than 0, concave down. The typical example to remember concave up, remember this curve x squared. This is a typical example concave up. And for concave down, remember negative x squared. This is a typical example of concave down. And how do I know x squared is concave up? You found the second derivative. How do I find second derivative? You found the first derivative first. So if fx equal to x squared, the derivative of x squared is 2x, right? And the second derivative, to take the derivative of first derivative. So 2x derivative, it is just 2. 2 is absolutely positive number. 2 always greater than 0. So we get conclusion, f prime, f second derivative greater than 0. When second derivative greater than 0, the function is concave up. So x squared is concave up. Now let's do fx. If fx, maybe I want you to use gx. If gx equal to negative x squared, if gx negative squared, the first derivative is negative 2x. The second derivative is -2. -2 always smaller than 0. Now we get g second derivative smaller than 0, so negative x squared is concave down. Concave down. Any questions? Concave up, concave down, based on second derivative. Second derivative positive, concave up. Second derivative negative, concave down. And this one determine the intervals of a concave. So 2 steps. 1, found the second derivative is 0 or second derivative is not defined. Once you found some numbers, those numbers either make second derivative 0 or the number make second derivative not exist. Those are this number. This number refer to second derivative equal to 0 or second derivative does not exist. Once you identify these numbers, you can identify the open intervals. Okay. So if you got 2 numbers that make second derivative is 0, you have 3 open space. This is x1, this is x2. This is interval 1, interval 2, interval 3. You have open intervals, 3 open intervals. And step 2, determine the sign of second derivative. If second derivative greater than 0, f is concave up. Second derivative smaller than 0, f concave down. Any questions? Okay, shall we take our first break? Come back at 7 o'clock, we continue the lecture. When we finish the lecture, I will go over 10 questions about practice test 1. Okay. Yes.
I have a question about the exam that we have this Friday test. Is it crucial to 47, right? The location of the test, also 247 at 7 p.m. And also, do we need to bring computers or something to use your camera or
It is a paper test.
it? 67 space. It's also showing section and the all
You officially section 2 months, 1 you know it from section 5. 2 you go to the rejected office after you move your names from section 5. No， 这量体等这个不是一体等这个是量体等这个人没有名字的量体等这个一体。
这个对应要找他这个等这个就是
为啥要给这个难题等这个是为了找到它是相对 up 还是相对 down， 这个看出来是这个样子的，是什么事情？
他这个等于就是这个找他那个一体的或者
一体很真，有的时候我们就你很少一体和一体，不要紧，就是在思考，这个很好。量体是管那个，专门管是康复的 up 或者康复的 down， 量体。一体是在管，是体现是上升，还是体现是下升？
那他这个就是为什么还有这个脑米饭？
就是说对于脑米饭的一些地方，也有可能帮助我们回答，就是康复。
但这儿不是就是写着，如果这个就是别档次，那大于这个就是那个小于档次，那就是还有这个
You can come over here. Very good question. If you don't, your question is, why do we need to find 0 or does not exist? Why we need this? The purpose of need this is we want the open intervals like this, interval here, interval here, interval here, and then the point C. Maybe C is here, maybe C is here, maybe C is here. Otherwise, where is C? You don't know. That's why we need this step. In order to locate C, is here or here or here. Otherwise, where is C? C here. Good question. Yeah. Okay.
Oh my God. That's like some interesting recipe.
Okay, welcome back from break. Hope you have had a nice break. Any questions before we move on? Okay, example. Determine where the graph is concave up, where is concave down. So if you want to decide concave up or concave down, you must find the second derivative. To find the second derivative, you need the first derivative. So questions on the fourth derivative, polynomial derivative, very easy, okay? This is the original function. Take a derivative of each item. You get this fourth derivative. And then from the second derivative, you get 6x minus 6. And set second derivative equal to 0. When second derivative equal to 0, you get x equal to 1. Why do we need to solve second derivative equal to 0? We want to divide the real number into parts, into interval. Where? Is it here, here, or here? Based on second derivative equal to 0, we get x equal to 1. Now we understand the interval, this is 1, this is 0, not 0. We just get 1, number 1. And this number 1, divide the real number in two parts. One is smaller than 1. The other is greater than 1. Okay. So use the interval notation. You get negative infinity to 1. And another interval is 1 to positive interval. 2 interval. And how do we know it is concave up or concave down? We examine second derivative. If second derivative greater than 0, concave up. If second derivative smaller than 0, concave down. And to do that, we have to pick a point C. And how do I know where is C coming from? Which one is C? Pick any point here as a C in fourth interval, negative infinity to 1. Okay, and pick any C here in another interval, 1 to infinity. So, can somebody help us to pick a number belong negative infinity to 1? Anyone? Please pick a number belong negative 1 to 1. Negative 24. Thank you so much. So this is my C if you pick negative 25 or whatever negative 1. This is my C. Okay? And now you calculate FC, second derivative at C. So second derivative is 6. X minus 1, right? So you are saying you pick C equal to negative 25. Do you see this number smaller than 0? You don't need the result. You just need to know second derivative greater than 0 or smaller than 0. You don't need to final result. You know this number is negative. Okay? So when you have a second derivative smaller than 0, what is said here? Concave up. Second derivative greater than 0, concave up, means the curve at this point from here to here is concave up. Any questions? From negative infinity to 1, it is concave up. Now I need another volunteer to pick a point C from 1 to infinity. Any number from 1 to infinity, yes?
3.
Thank you so much. C equal to 3, okay, from 1 to positive. And we need to find out second derivative at 3. C is my 3. So x minus 1 equal to 6. 3 minus 1. You don't need to result, but this is simple result. 12 greater than 0. You pick any number from 1 to infinity. C equal to 3. When second derivative greater than 0, concave down. Second derivative greater than 0, concave up. Did I say something wrong here? Second derivative smaller than 0. See, I made mistake. Concave down here. Second derivative greater than 0, concave up. Hope from this example you understand what is C, why we need C. C is a number in the interval. And how do I determine this interval? You make second derivative equal to 0, you get the interval. That point will divide the intervals. So final conclusion, concave up is from 1 to positive infinity. Concave down from negative infinity to 1. That is final conclusion. Any questions? Okay, and this is the graph of original function. This is the original function. You can easily plug in, type in the expression in GeoGebra. You will get this graph. So this one is number 1. Okay, you see when x smaller than 1, concave down. When x greater than 1, concave up. Concave down, concave up. Questions? Another new concept, inflection point. Inflection point. So what is an inflection point? When you have a concavity change, it is a point of inflection. What is a concavity change? Means from concave up to concave down, or from concave down to concave up. That is a concavity change. Now look at this graph. Can you find a point? The concave changed. At which point it is changed from concave down to concave up? 1. At 1, it is changed from concave down to concave up. So 1 is an inflection point. 1 is the inflection point because it is changed from concave down to concave up. Let's look at this example. Find the inflection point of f equal to x cubed. So to find the inflection point, we need the second derivative. To find the second derivative, we need the first derivative. So we know the derivative of x cubed is 3x squared. And then second derivative 6x. So how do I find inflection point? Compute second derivative first, and then determine the numbers where second derivative equal to 0 or second derivative does not exist. So now let second derivative equal to 0, and you got x equal to 0. And once you got this one, step 3, determine the sign of second derivative to the left and right of the number. Found this number c in step 2. In our example, this number is c. 0 is the number c in the this one here. And then we need to find, so this 0 divide the real number in 2 parts, smaller than 0, greater than 0. Okay. And now when x smaller than 0, what is the second derivative? The second derivative is 6x. Second derivative is 6x. When x smaller than 0, it is negative. See, negative here. Second derivative is negative. And when x is greater than 0, second derivative is positive. Did you see second derivative changed from negative to positive? Second derivative changed from negative to positive. Okay. Therefore, 0 is the inflection point. 0 is the inflection point. Because second derivative, this part, when you do the second derivative smaller than 0, and this part, when you do second derivative, it is greater than 0. So changed from negative to positive. Not the function itself, second derivative. Any questions? How do you find the inflection point? Okay. A new concept, second derivative test. And this one connect second derivative with a critical number. Remember what is a critical number? First derivative equal to 0, that x is a critical number. First derivative equal to 0, that x is a critical number. And this graph shows that f has relative maximum at x equal to c. Why? Because second derivative smaller than 0. Second derivative is a negative number. And this graph shows this point is a relative minimum because the graph is concave up. When the graph or the second derivative is greater than 0. Second derivative. This is the second derivative test. Do first derivative, then do second derivative. Find the critical numbers. How do you find critical number? First derivative equal to 0, those x are critical numbers. And then compute the second derivative at critical numbers. If second derivative is smaller than 0, you have relative maximum. Second derivative greater than 0, relative minimum. Second derivative equal to 0, this test inconclusive. This second derivative test, connect first derivative, second derivative, connect critical numbers, connect relative maximum, relative minimum, combine all these concepts in one test. That is second derivative test. Combine all these concepts into one. The optimal goal, we want to find the relative maximum, relative minimum. That is our purpose. To find the relative maximum, relative minimum, we need first derivative, second derivative. We need critical numbers. The final objective to determine if f has relative maximum or if f has a relative minimum. Example. Found the relative if you have found the relative extrema, means found the relative maxima or relative minima. Given function to determine the relative maxima or relative minima. And how? Found the first derivative first. And then found the critical number. How do you find the critical number? First derivative equal to 0, you get a critical number. By definition, critical numbers are the number that make first derivative equal to 0. So obviously from here, we know x equal to -2 and x equal to 4. Those are critical numbers because they make first derivative equal to 0. Questions? Once we found the critical number, so what? We need to find the second derivative. Remember what is the first derivative? This is first derivative. So second derivative would be 6x minus 6. Second derivative. And then, once we found the second derivative, and remember the critical number, what is the purpose of the critical numbers? -2, 4. Those numbers in order to divide the real number into intervals. -2 is here, 4 is here. As you can see, we have 3 intervals. One is from -infinity to -2. One is from -2 to 4, and then one is 4 to positive infinity. Those are the function of critical numbers. Divide the real number into the intervals. And now, we based on this theorem, compute second derivative at C. So what is C again? C is the critical numbers. So in this case, C equal to -2, C equal to 4. Okay, so we need to compute second derivative at -2. Second derivative at -2 is a negative number. When it is a negative number, it has a relative maximum. Second derivative negative number means it has a relative maximum. Okay, so we did this one here. Okay, C, but we have two C. One C equal to -2, another C equal to 4. We have to do when C equal to 4. Questions? Okay. So when C equal to 4, we need to figure out derivative 4. 6, 4 minus 1, this number greater than 0. That means F4 is relative minimum. Relative minimum. Because second derivative greater than 0. Any questions? Okay, so if I were you, after this lecture, I will just look at this part to see if I can find the relative maximum, relative minimum. If I am stuck, I look at the solution here. So take the example as exercise when you go home. This one is a summary table comparing the first and second derivative test. If the first derivative is positive, means f is increasing. If second derivative is positive, means it's concave up. If first derivative is positive, means f is increasing. Second derivative smaller than 0, it is concave down. But this, if you do the combination here, this is a combination, okay? So when you do the combination, when first derivative positive, second derivative positive, the graph looks like this. This means first derivative greater than 0 because f is increasing. And also second derivative greater than 0, it is concave up. Maybe, okay, it's like this. Now combine these two. First derivative greater than 0, so it is increasing. But second derivative smaller than 0, concave down. So it is this graph. Increasing, but concave down. And then this situation. First derivative smaller than 0, Second derivative greater than 0. So look at the fourth derivative smaller than 0. It is decreasing. But the second derivative greater than 0, concave up. Concave up. Last situation. Fourth derivative smaller than 0. Second derivative smaller than 0. Fourth derivative smaller than 0 decreasing, is decreasing. Second derivative smaller than 0 concave down. Concave down. Any questions? So this slide summarizes fourth derivative and second derivative. Based on fourth derivative and second derivative, we can predict, we can get a big picture of the shape of the original function f, increasing or decreasing, concave up or concave down. Questions? That concludes the lecture part of today's lecture. So in summary, we did chapter 4, session 1, chapter 4, session 2. Okay. In chapter 1, session 1, we did the application of fourth derivative application. And then session 2, we did the relative maximum, relative minimum, concave up, concave down, increasing, decreasing. Okay. Any questions? Remember, if after the lecture, if you have questions, what do? You go to Mathematics Learning Center. Virtually every day, somebody is there. Another way to get help, you can email me for specific questions. When you email me, please allow 2 business days to have your email answered. If we have a test, for example, we have test 1 February the 10th. If you email me on February the 9th, you may not get reply on February the 10th because it may take 2 business days. So I would strongly suggest you go Mathematics Learning Center. Okay, but I will reply your email within 2 business days. So that concludes the lecture for today. And next, we'll go over practical questions for the midterm. You can get those questions from Brightspace. So everybody go to Brightspace, pull out the question. And if you click this PDF file, you get the help hour for this week, maybe you need help the most. So if you scroll down, February. So this is this week. So this is today. I had office hours 4 to 5:50 here. Tomorrow, Professor Huda is there. She is also teaching MATH1p97. Okay. And Wednesday, Professor Huda. And we have Neil Marshall. He is the manager of Mathematics Learning Center. Is also help with 1p98. And Wednesday also have a TA. Okay, see, every day somebody is there. Every day. Okay. So this is help hours. And then the questions, review questions. You go to term test 1 review. Term test 1 review. And there are 10 questions here. Term test review. And I will go over those 10 questions. Okay. So those are the questions. You can find the question on the bright space. Okay. Fourth question, found the composite of function f over g if f is the square root of x minus 1, g is x squared plus 2. And then I will give you another question. Found the g composite with f. So let's do this first. F composite with g. Okay, this is then we'll do this one. So f, maybe I will erase this one to avoid confusion. F over g means whenever you see fx, instead of x, you plug in g. Okay, so fg equal to, whenever you see x, you plug in g. This is g, x squared plus 2. Copy down everything else. Whenever you see x in f, plug in g. And then you just simplify this one. That's it. And now, if the question asks you g composite with f, whenever you see x in g, plug in f. Yes?
Why is it x squared plus 1? Like the square root of x squared plus 1.
Why it is x squared plus 2?
Equals square root of x squared plus 1.
Oh, you just take away, maybe I will make step by step. If I take away the square, it would be, take away the bracket. Did you see? Just take away the bracket. Thank you for asking. Then it becomes this one. Okay, next I will do GF. Yes, questions?
Could you not simplify that further by just putting the square root over the 1, because x squared, the square root is just x.
Thank you, but that is a big mistake if you do that. But thank you for raising that question. Okay. Question is, can you simplify this one to this? No, no, no. Big no, no, no. Because this square root controls the whole x squared plus 1. You cannot do this. You cannot say equal to, this is big no. Okay. Thank you for asking. Okay. So this is the final result. You cannot simplify. So next, I will do GF. Means when you say x in G, plug in F. When you say x in G, plug in F. So this is G. When you see x in G, plug in F. Okay. So this is F. 1 squared plus 2. When you see X in G, plug in F. And then simplify this one, you get this one. And simplify, you get this one. Questions? Question 2, find the limits. Show your work. When you have this kind of question, usually the first step, you can just try to plug in 2. If you plug in x equal to 2, what happens? When you see x, plug 2. When you see x, plug 2. And you will see 4 minus 6 plus 2. 4 minus 2 minus 2. And you will see 0 over 0. This is undefined. When you have 0 over 0, undefined. Okay? So you don't do this. You don't do plug in because undefined. And you have to do some work. Okay? So don't do this. This is on the side on your rough paper. So what you do, you factor out, you factor the numerator and the denominator. So on the top, it is equal to x minus 1, x minus 2. On the bottom, it is x minus 2, x plus 1. You need to do this first. Factor denominator and numerator. And then you notice the canceled out. X minus 2 canceled with minus 2. On top, you have x minus 1, bottom x plus 1. Now you plug in x equal to 2. And this is the final result, 1 over 3. Yes?
What do you do if you don't have any values on top or bottom that we factor down?
Say that again.
If you don't have any values on the numerator or the denominator that can be factored out, should you just leave them as they are?
If you don't have anything cancelled out on the top and on the bottom, you still need to continue to plug in the number to see if it is undefined. You work another way.
Okay, so okay. The limit is...
Usually there will be cancel out.
Okay.
Usually, okay. Yes.
Would you, since the first area mentions that it's undefined, do you not even do that at all, or do you have to have that be included within it?
Thank you. When you do this plug in 2 directly, you reached out undefined. Can you stop here? No. This is just you explore. You say, oh, undefined. So that means you cannot directly plug in. You need to do some algebra. You need to do some manipulations. You need to apply some techniques. See, our final result is 1 over 3. We get this. Yeah, you need to explore other ways. Directly plugging does not work. Other questions?
You have to show that it's undefined when you come.
Oh, when you do your work, you don't need to do this part. You just do this part on the side. You just need to show this part. Thank you. B, when x goes to infinity. When x goes to infinity, during the lecture, I told you the rule. When x goes to infinity, you will And when the degree on the top with the degree on the bottom are equal, it is just the coefficient, the ratio of the coefficient. And I said there are conditions. Condition 1, x goes to infinity. Condition 2, the degree on the top is equal to the degree on the bottom. And then you just use the coefficient, the number in front of the highest degree. This is the fast way. But when you are asked to show your work, you cannot do this way, okay? When you are asked to show your work, you do this way. Both the top and the bottom, you divide it by x squared. Both the top numerator, denominator divided by x squared. And then simplify the top, it is just 7 plus 1 over x minus 100 over x squared. This is on the top. On the bottom, 2 minus 5 over x. This is the limit. X go to infinity. And then you apply a basic knowledge. When x is very big, 1 over x is 0. And when x is very big, 1 over x squared is 0. Okay? And then you get 7 plus 0 minus 0, 2 minus 0. It is 7 over 2. But this is the basic fact you need to know, realize. When x is very big, 1 over a very big number equal to 0. Yes?
I'm just a little bit confused. Where did you get 2x squared minus 3x over x squared?
Sorry, which part?
Where did you get 2x squared minus 3x? Oh, sorry, my
Sorry.
bad, 5x.
Sorry for my handwriting, 5x.
No, that's my bad, thank you.
Yeah, this is the original question here. Yeah, thank you for asking. This is the original question. Okay, I'll try to make my handwritten readable. Yeah. Questions? Yes.
Does the rule still work when x goes negative?
Yes, the rule still work if x is thank you. Brilliant question. If I change this question to x approach to negative infinity, it is still the same answer, 7 over 2. Yeah. Okay, question C. Found the limit. So first, when you try to directly plug in x equal to 4, you would get this. 4 plus 5. If you directly plug in x equal to 4, 4 minus 4, what you get is 3 minus 3, 4 minus 4, and you will get 0 over 0, undefined. And that alert you, you need to do some manipulation. So this one is just something on side. So you need to start from here. When you see the square, you usually times the opposite. Okay, I'll do this. Both numerator and denominator will times square root of x plus 5 plus 3 x plus 5 plus 3. So I didn't do anything. I just times the same item on both numerator and denominator. Any questions? The reason I am doing this, can you hear me? The reason I am doing this, I want to get rid of the square root. I want to get rid of that one. So I simplify something on the bottom. I get x plus 5 minus 3 squared. And then the bottom, I copy it down. And then it is still limit LIM and x goes to 4. Questions on simplify something on the numerator. And then continue. So 5 minus 3 squared is 9. So it becomes 5 minus 4 on the top. On the bottom, you have x minus 4, x plus 5 plus 3. So still have a limit, x goes to 4. And do you see the cancel out? X minus 4 canceled out. X minus 4 on the top canceled out with x minus 4 on the bottom. Yes?
We don't write limit every single time. Will words be taken up?
If you do not write the limit every single time,
Yeah, like when you're going through the steps, if you don't write limit x approaches forward, will we get marks taken off?
you will get mark, you will deduct mark because it is not mathematically correct. So each step we are doing here, when you do your rough work, you can eliminate LIM each time. But when you actually write during the time, you need LIM x approach to 4 each step. Okay. So now on the top, I got 1. On the bottom, square root of x plus 5 plus 3. Now keep on going. Now you plug in x equal to 4. So it is square root of 4 plus 5 plus 3. So 1/6 is the final answer. Yes.
I'm just a little bit confused. I didn't get x plus 5 minus 3 squared from x plus 5 square root minus 3 times x plus 5 square root plus 3.
Thank you. How do I know these two bracket terms together equal to x plus 5 minus 3 squared? Thank you. How do I know? It is based on this basic formula. A minus B times A plus B equal to A squared minus B squared based on this formula.
Oh, okay.
Okay, thank you for asking. Any other questions? You're welcome. Do you want a break or you want to, we just solved 3 questions. There are total 10 questions. You want a break or you want to continue once we've done the 10 questions? But I promised one student to do some questions about differentiate implicitly. Maybe I will do 2 or 3 questions about that. So do you want to continue or you want second break? That is the question. Maybe second break. Okay, so come back at 8 o'clock, we continue the rest of the questions, and I will do whatever you ask me to do. So one is do more questions, implicit derivative. Okay.
I'm confused on how you got the plus 3 from this. Sorry, that's the only part of that.
Thank you so much. So this is this question, right?
Yes.
I want to get rid of this square root.
Yes.
To do that, this is minus 3,
Yes.
our times plus 3. So that I will get rid of it is square root, but there is no square root here.
I see. Okay.
Use this formula here.
Yeah. Okay, that makes sense.
Okay,
And then,
yeah.
because you're canceling out the square roots
Yeah,
to
yeah,
get rid of
yeah.
that. Perfect. So, there's 10 questions on the term test?
Like probably 7 or 8.
7 or 8, and they're like these ones?
Yeah, they all like this one.
Thank you. I didn't want to. So here, how I did it, would it equal 0? I can show you. I might have written it down now.
Yeah, show me your work.
So when you go x plus 5 minus, so that would be 9, right?
Yeah, yeah.
So if you were to add those together, it would be -4.
Correct.
So 4 minus 4, would that be 0?
Oh, thank you. Oh, no. You don't plug in x equal to 4. You just do the manipulation. Forget x equal to 4.
Okay.
You just simplify this. It is x minus 4, right?
Yeah.
And then cancel out with x minus 4 here.
Oh.
You
okay.
plug in x too early.
Oh, okay. So then this, so I need to fix it here then.
Right.
So then this is,
Yeah.
this is gone. And then this is 1. And then that's where you get your 6 from.
Correct.
So this-
Perfect.
And then I had 6 down here. Okay.
You are
thanks.
thinking great.
Thanks.
Great.
I didn't think of
Great
that.
exploration.
Okay, thank you.
Thank you, Mr. Anderson.
Also, last week we went over the verification for the derivative, right?
Yeah.
And we went over all this, so we don't need to know it for the test, right?
We need to know.
you do?
Come.
This is very long.
Yeah, use definition to show this. See, use definition of limited to show this. So it is the same procedure as I showed last time.
Oh, I see.
We need this.
Okay, all right.
Question.
Camera.
Yes. We got
Try to
for
remember.
this one. So we got 0 out of 0 over 0, which is undefined. How do you know it does not exist?
Undefined means maybe exist, maybe not exist.
When would it be does not exist? When it's like 1 over 0? Or 0 over 1?
It would be 1 over 0. 0 over 1 exists. 0 over 1 it is 0. But 1 over 0 it is infinity.
Okay. Infinity or does not exist.
Yeah.
Okay.
Both correct. Infinity or does not. Yeah.
So if it's 1 over 0, then it's infinity or doesn't exist. But if it's 0 over 1,
It is 0.
it's 0.
It is exist.
Okay. Thank you.
You. All right, so we continue. Any questions before we do the following questions? Question 4, find the domain of the function. And this function has a square root, and this function has numerator denominator. When you have a square root, the expression inside square root must be greater or equal to 0. This square root is our numerator position. If the square root is a denominator position, it should be just greater 0. But here, our square root on numerator position, so it could be 0. And then on denominator, we have two denominator. Something used as denominator must not equal to 0. So the denominator is x plus 4 minus times x minus 3. This must not equal to 0. And from equation 1, we get x greater equal to 1. And from equation 2, we get x not equal to -4, x not equal to 3. And this is and. And the question asks you to use interval notation. So we have to translate our result into interval. This is our result, but this is not enough. You have to use interval notation. So how do you use interval notation? You draw a straight line, and then label 0, label 1. So x greater equal to 1, it is this part, x greater equal to 1. But then x not equal to -4. So this is 1, 2, 3, 4. This is -4. This is -1. When something not equal on the straight line, you use a circle represent not equal to -4. And not equal to 3. This is 1, 2, 3. So use a circle represent not equal to 3, okay, and then, so what is the common part? So x must be greater equal to 1. So we actually ignored this part. We ignored because x must be greater equal to 1. Do you see that? X must be equal to greater to 1. And then x not equal to 3. And so this, we can write down this. It is actually this part and this part. So it is actually interval notation. It is 1, 2, 3. I use a square bracket, means x could be equal to 1. I use the round bracket, means x is not equal to 3. And union with 3 to positive infinity. So this is the interval notation. Final answer should be this format. Questions? Not sure. I think because we have this expression, so I'm going to, because this is important on fundamental. This is another question, okay? Because in chapter 1, remember you are asked to solve inequality. For example, solve this question here. This is separate question, okay? Separate question. The question asks you to solve x plus 4, x minus 3 greater 0. I just want to give you 1 minute, talk with your neighbor. I want to see how can you solve this question. I give you 1 minute to do this question. Solve x plus 4 times x minus 3 greater than 0. The purpose I give you this question, I want to introduce a fast, accurate way to solve quadratic inequality. Again, this is a separate question, okay? Independent with any other questions. Okay, there are many different ways to do it. One fast and effective way is to use the quadratic function. Remember this, if you expand, it is a quadratic function. Quadratic function, either concave up or concave down. This is quadratic function. Okay, either concave up or concave down. So how do I know it is concave up or concave down? You look at the coefficient of x squared. So if you expand this, you get x squared plus x minus 12. The coefficient of x squared in this case is 1, is greater than 0. If the general format is ax squared plus bx plus c, this is quadratic, right? If a greater than 0, concave up. If a smaller than 0, concave down. Okay? And once you have this principle and solve quadratic inequality is very easy. First, identify concave up or concave down. In our case, this is concave up. Okay? Because a is greater than 0, coefficient of x squared. Second, identify the root of the quadratic equation. If you let this quadratic equal to 0, if you let equal to 0, what you get is x equal to -4 and x equal to +3. Question so far? And now, the question asks you to solve for greater 0, not equal to 0. The question asks you, which part is greater than 0? Look at the graph. Directly look at the graph. This part greater than 0, this part greater than 0. Do you agree? This greater than 0, this greater than 0. And then you directly give answer. The answer is -∞ to 4 or 3 to +∞. This is interval notation, or you can write down x smaller -4, x greater 3. If you take x from smaller than -4, or take x from greater than 3, you will have this one greater 0. And this is the fast way to solve quadratic inequality. Okay, and similarly, if again, this is separate. If I ask you to solve x plus 4, x minus 3, smaller than 0. By directly looking at this graph, the solution is x smaller than 3, greater than -4, because see, this part is smaller than 0. This part here, smaller than 0. This is the answer, -4 to 3 will make this quadratic smaller than 0. Just directly looking at the graph, you can solve inequality for the quadratic function. So again, those are the separate questions, okay? Questions? Now we move on question 5. Determine if fx is continuous. Show your work. To determine if a function is continuous, you do 3 things. 1, 2, 3. You must do those 3 conditions, all the 3 steps. Step 1, find f0, because the question asks you if it is continuous at x equal to 0. Find f0. When x equal to 0, you go this expression, go to here, plug in this equation. So you get square root 4 minus 0 squared equal to 2. Okay. And second, you need to find the limit of f0, because this original function has 2 parts. One is smaller 0, the other is greater equal to 0. So you need to find the limit x goes to 0 from left side. And you need to find x goes to 0 from right hand side. You need to find 2. Fx, Fx. When x goes to 0 from left hand side, you need to use x plus 2. When x goes to 0 from left, so you plug in, you got limit is 2. And when x goes to 0 from right hand side, you use the square root of 4 minus 0 equal to 2. Okay, so from step 2, left limit equal to right limit. So the limit when x goes to 0 equal to 2, that is step 2. Step 3, when f0 equal to the limit of fx when x goes to 0, they are equal. Because f0 is 2, limit of fx when x goes to 0 is also 2. Only when these 3 conditions, you follow these 3 steps, then you conclude fx is continuous at x equal to 0. Questions? You're welcome. Question 6. Use definition of derivative. Remember last class we did use definition of derivative to verify quotient rule. And this one, use definition. Looks like each semester we like this question. We have this question on the midterm test 1. Okay. And this question is also on your written assignment 2. The fourth question in written assignment 2 is this kind of question. And remember, we need 4 steps. Okay? So to find the derivative of fx, step 1, you need to find x plus h. Step 2, minus fx. Step 3, divided by h. Step 4, take derivative, h goes to 0. This is definition of a derivative. And then you just, each time you have to write down limit, h goes to 0. So what is fx plus h? Whenever you see x here, plug in x plus h. Whenever you see x plus, plug in x plus h. Whenever you see x, plug in x plus h. So that is fx plus h. Then minus fx means minus original function. Minus fx and over h. Questions? Now you expand the top, you simplify the top, the numerator. So 3x squared plus 2xh plus h squared minus 5x minus 5h minus, just take away the bracket over h. And then you take away the fourth bracket, the top becomes there is a limit. I forgot h goes to 0, h goes to 0, this is 0. Yes.
You have to multiply the 3 and the 8 squared as well.
Thank you so much. Yes, for sure. I need this 3. Thank you. You are paying attention and paying detail. Plus 3x squared. And then on the top, you have some cancellation. Positive 3x squared, negative 3x squared. Negative 5x, positive 5x. You cancel, oops. You cancel out. So I continue here, okay. Limit. So on top, you have 6xh plus 3h squared minus 5h. On the bottom, you have h. Each item you have h, so you get, eliminate one h, you got 6x plus 3h minus 5. Each item divided by h. And now you got the result. Plug in h equal to 0, h equal to 0, you got 6x minus 5. Okay, so we got the result. Use definition to find the derivative. If not use definition, ask you to find derivative. Everybody should know it is 6x minus 5, right? 6x minus 5, not use definition, just use the rule. But now we use definition to get 6x minus 5. Questions? Now part B, use the equation of the tangent line to the curve 3x squared minus 5x at the point 2, 2. Found the tangent line. To find the tangent line, you are given a point. In high school, if you have the slope, if you have a point, you can write down a straight line. So here we need to find the slope. The slope is the derivative of the function. The derivative is the slope. Okay. So this derivative is 6x minus 5. We already got it. And this derivative when x equal to 2, y2 here, it is given this point, x equal to 2. Equal to 6 times 2 minus 5 equal to 7. So the derivative is 7. And the point is 2, 2. What is this straight line? Okay. Point is 2, 2. Slope is 7. So the straight line or tangent line equal to y minus y0 equal to slope times x minus x0. But the question asks you in format y equal to mx plus b. So you need to move 2 over to the right hand side. 7x minus 14 plus 2. Y equal to 7x minus 12. That is the final answer. The tangent line. Questions? Question 7, differentiate implicitly. And I will do 2 or 3 more questions about this at a request of one student at the beginning of class, okay? Differentiate implicitly with respect to x. When you do the implicitly, remember a rule, x is x, f or y, x is x, y has x. So both sides you differentiate. Right hand side when you differentiate, it is 3x minus y raised to power 2. And then chain rule times x minus y derivative. This is left hand side. Right hand side, xy derivative, 1 derivative. You derivative both sides. Left hand side, we use the chain rule. And now continue left hand side, x minus y squared. So x minus y derivative, it is x derivative minus y derivative equal to x times y derivative, use the product rule, f times g derivative equal to and this one is it is equal to fg prime plus gf prime product rule, derivative product rule. Apply this to right hand side. So it is xy prime plus y x prime. 1 constant derivative is 0. Questions? And now continue. X derivative is 1. Y derivative is just y derivative. Right hand side, x derivative is 1. And now, our objective is to solve for y prime. We want to solve what is y prime equal to. And I see y prime here, y prime here. Okay? So now we are going to you consider this part is a big item, is a box. If I have, for example, x times x minus y, x times a equal to ax minus y times a minus ay. Apply this to this part, left-hand side. Consider a is a big box. 3 times this bracket is your a. Consider a equal to 3 times. Apply this formula for right-hand side. So I use 1 times this one, so I get 3. Then I use y prime times this big item, minus 3. This is left-hand side. And right-hand side, I just copy down. Now I can collect like term. I see y prime. So I will move this xy prime to the left-hand side. So I get, copy down this one. So actually I want to move this one. I want to move this plus y to left-hand side becomes negative y. And move this item to right-hand side, it becomes positive 3. I just moved item around. The purpose is to collect like term y prime. I want to collect like term. So after that, right-hand side, I factor y prime out, and I have x plus 3, x minus y squared. This is right-hand side. Left-hand side, I just copy down. And now, one step away, you get final answer, y prime. So both equation, you divide it by x plus 3, x minus 3. Both left-hand side, right-hand side, you divide by the same item. And you cancel out this one. Right-hand side, you just have y prime. Left-hand side, so this is your final answer. Remember prime, y prime is the same as dy dx, the same thing. Okay, what is y prime? This is final answer. Maybe you need to switch left hand with right hand side. Maybe you need to switch right on this, y prime equal to 3x. Final answer. Any questions? So this is a differentiate implicitly, yes.
Why can't you cancel the 3x minus y squared?
Thank you. Why can't I cancel 3x minus y squared? Because they are not multiplication. This part you have minus. This part you have plus. You cannot cancel this one with this one. No, you can't. If this minus is a multiplication, and if this plus is multiplication, yes, you can cancel them out. But now I got minus, I got plus. You cannot cancel 3x minus y squared. Other questions? So this is just part A. Part B, find the slope of the curve from part A at point 1, 0. Find the slope. Remember, the slope is the derivative, okay? And I already found the derivative. So just plug in x equal to 1, y equal to 0. You found the slope. X is 1, y is 0. Okay? So part B, x is 1, y is 0. X is 1, y is 0. Found out this one. This is final answer. Questions? Again, when you go home, redo those 10 questions. You must redo them again and again and again until you very fluent, very comfortable with each and every question. And do some more questions similar to the question, for example, the implicit. Take some questions from textbook example. Take some questions from in-class example. Redo them. Question 8. Differentiate. Do not simplify. So this one use product rule. This is fx. This is gx. So f times g derivative equal to fg derivative plus gf derivative. Use this rule. So y prime equal to f, this is f, g prime plus g, f prime means derivative. Strictly apply formula first. And then copy down this one. Derivative of 3x squared is 6x. 5 derivative is 0. Constant derivative is 0. And then derivative of, I need to do on the side. What is the derivative of this guy? I need to do this, okay? 1 over square root of x derivative equal to x negative 1 over 2 derivative. And then I apply xn derivative equal to n xn minus 1. So equal to negative 1 over 2, x negative 1 over 2 minus 1. And equal to negative 1 over 2, x negative 3 over 2. So I copy down this result into here. So negative 1 over 2 times x with negative 3 over 2. And then it is said do not simplify. So even it said do not simplify, you can still make a little bit arrangement. So 6x times this item, and then negative 1 over 2, x raised to power negative 3 over 2. I just rearrange the item. This is the final answer. Questions? Okay, this is a question A. Question B, found the derivative fx equal to square root. So we know what is the derivative of square root. It is x raised to power 1 over 2 derivative. 1 over 2x minus 1. It is 1 over 2x negative 1 over 2. Or you can write down it is 1. This is the same as 2 times square root of x. 1 over 2 times square root of x. If you can remember this result, it will speed up your calculation process. Which result? Square root of x derivative equal to 1 over 2 times square root of x. Okay, so b equal to, but b, you need to apply chain rule because this is the square root of polynomial. It is not just square root of x. Okay, so you need to apply chain rule. But first, apply this formula. What is the derivative of square root? So it is 2 times this bracket or this square root. It is 1 over 2 times original function. Right? And then chain rule. I need this part. Erase this one. Because this is just a side work, something on the side. Chain rule said you have to take derivative of this guy. That is your step 1. Apply derivative of square root of x, then apply chain rule. And then equal to this time, you just copy down the denominator. On the top, derivative, it is 4x plus 4. And then, that's it, because it said do not simplify. But if you simplify a little bit, that's fine. Both numerator and denominator, you divide it by 2. Both numerator and denominator, you divide it by 2. And this is your final answer. Questions? When you go home, redo this question and redo similar question in examples in the textbook, redo similar question in class in the example. Okay, focus on examples. The reason is you have detailed solutions. If you're stuck, you can take solution. If you don't stuck, you have correct answer to compare. Only after you feel comfortable with each and every example, then you can go to exercise in the textbook, do extra stuff. Question C, we need a quotient rule. So f over g quotient rule, derivative equal to g squared. G this is the quotient rule. Directly apply this quotient rule, you have f prime equal to And now copy down the denominator and work for the numerator. The first item, x minus 1 derivative, it is 1 times 1. And then x squared plus 3x derivative, 2x plus 3. Now continue, simplify the numerator. Continue, take away bracket for the numerator. Copy down the bottom. And then collect like term on the numerator. Any questions? Actually, the question asks you not simplify. So if you can just live up to this step, it's also considered correct. If you are here, because the question said do not simplify to save you some time. Okay. So if you stop here, that's also correct. Questions? Oh, yes.
I got x squared plus 4x, sorry, negative x squared plus 4x times 3 instead of the answer you got for the numerator.
Sorry, which part?
For the final answer, I got negative x squared plus 4x minus 3 for the numerator.
Oh, okay, thank you for the numerator. Let me double check. So negative x squared, positive 2x, negative x is positive, positive 3x, negative x is positive 2x. I believe this is correct. Yes.
When you drop the brackets, you change -3 to +3.
So when I drop this bracket, -3 becomes +3, right? Yeah, correct. Thank you. Any other questions? Thank you for that student point. This is -3, but when I drop the bracket, it becomes +3. Okay. Any other questions? We have 2 questions left, and we have 4 minutes. Okay, so I'm going to speed up a little bit. Question 9. You have selling price for each unit is $10. selling price for each unit $10. The profit is given by this function. Question A, for which value of x is that profit greater than 0? So you just need to solve this inequality. And remember, this is the quadratic function. The coefficient of x squared is negative. This quadratic function must be concave down. Coefficient of x squared smaller than 0. And then the fast, effective way to solve the inequality, get what are the x so that it is equal to 0. So obviously, if you take x out, you get this. So one x is 0, another x is 20. So this is 0, this is 20. Those two numbers will enable the quadratic equal to 0. And then the question asks you greater 0. You tell me this graph, which part greater 0? This part greater 0, right? So the answer is x from 0 to 20. Final answer. If you write interval 0, 20, interval format. Looks like you need to master inequality for quadratic function. This is my way to do it. Solve equation first, decide concave up, concave down, then directly looking at the graph to get solution, greater 0 or smaller 0. So we solve for question A. Question B, determine the revenue function. You need to know revenue equal to unit price times number of quantity. Unit price is $10 given. So that is question B. Question C. Determine the cost function. The cost function equal to revenue minus profit. Revenue minus profit equal to cost. You need to know this. And what is the revenue function again? 10x is revenue. What is the profit? It is given 20x minus x squared. And simplify, you get x squared minus 10x. That is question 9. Question 10. You have fx found first derivative, second derivative, third derivative. So fourth derivative, 20x squared. Apply this formula, xn derivative n xn minus 1. This is fourth derivative. Second derivative. Third derivative. Okay. And we are just in time, finish the 10 questions. The rest of, maybe I promised the student for more questions about implicit differentiation. If you want to stay, you're welcome. If you don't, feel free to go. Thank you so much. I will take some questions for, it is optional, okay? The class time is end. Thank you so much, but I will provide 1 or 2 more examples about implicit differentiation, okay? And I'm going to take textbook questions. It is 3.6 implicit differentiation. Okay, I will do some maybe one question from this exercise, okay, implicit. Which one you want me to go through? The textbook provides answer for all the numbered questions, so I would do maybe 2 even numbered questions. Maybe I will do question 12, and then how many students? Okay, I will do question 12, then maybe 20 or 22, 24. You give me an answer number. So I will first of all copy this question to my OneNote. So let's do question 12 first. X. So I need space. Need to copy down the question. Double check, is this the question? Yeah. So the question asks you implicit differentiation. So you take the derivative on both sides. Left-hand side, you take a derivative. Right-hand side, take a derivative. So left-hand side, remember x is x, y has x. So x cubed differentiate is 3x squared. Y cubed differentiate 3y squared. But y has x, so you have to times y prime, the second item. Now y derivative, and the derivative of 4 is equal to 0. 0 derivative is 0. Okay, and now I collect like term because y prime here. So I have 3y squared plus 1 y prime. And I take 3x squared to the right-hand side, it becomes negative 3x squared. And now I solve for y prime equal to 3x squared over 3y squared plus 1. That's it. So this is one question. Another question. I will give you a moment to write down the notes. Let's pick another question, okay? This is a 12.
24.
Thank you, sure. 24, okay? And I see the square root. So side note, square root of x derivative, I ask you to remember this 1/2 square root of x. Use this. Okay, left-hand side derivative, right-hand side derivative, both side derivative. Left-hand side, you use this square root of derivative, and then you have to use a chain rule. Okay, let's do left-hand side. It is 1/2 xy, then chain rule. This is the left-hand side. Remember, we did similar example in one question in the out of 10 questions here. And right-hand side derivative, 2x derivative is just 2. Y squared derivative, 2y times y derivative. This is right-hand side. Because y has x, you cannot just write down 2y. 2y times y derivative. Continue left-hand side. And then xy derivative, you apply product rule, fg derivative. This is product rule. Okay. So apply this to x times y derivative. It is this plus gx derivative. Copy down right-hand side times y derivative. Continue left-hand side times, let me see, y prime, yeah, xy prime plus y. X derivative is 1. 2 plus 2y times y. Right-hand side, I just copy down. And now my objective to solve for y prime. So I need to remember this item times this, then this item times this. Remember we said a times x plus y equal to ax plus ay. Okay. So this times xy prime plus this times y, this is the left-hand side, right-hand side, y prime. And then y prime, I collect like a term. I will jump one step, move this to left, y collect the right term. There is an x here. So these two terms I move together, collect like term. And then I move this item to the right-hand side. And now I solve for y prime. and then simplify this result. Both denominator, numerator I times square root of xy. Both numerator and denominator are times square root of xy. I missed y here. And then both denominator, numerator I times 2. Just to simplify the rest of the work. So I believe this is the final result, the simplified format. And there are more examples on implicit differentiation, the textbook example. Go over textbook example because it provides detailed solutions. If you start, you have solutions, okay? That's all for today. Thank you so much for being so patient and supportive. Have a great week. Good luck on our test 1. Remember, go to Mathematics Learning Center, okay? Yes. Let me check. It is on 3.6 page number. I have to find out what is page number. Oh, 231, page 231. You are welcome.
Yes. In the previous question, can you directly apply product rule to square root of x and y? In the previous question, can you directly apply product rule to square x and y?
Which question? You have to tell me which question.
This question only, like instead of like using the chain rule, you can directly apply like the product rule? Cos root xy equals to root x into root y.
This part I apply product rule.
No, I'm saying can you directly apply like on this part?
Oh, you want to directly apply square root of x times square root of y, directly product rule?
Yeah.
Of course. Go ahead. Yes. Thank you. Okay.
I just wanted to say thank you for going.
Oh, you're welcome. Remind your name.
Emma.
Emma. Thank you, Emma, for raising that question.
Thank you.
I just have a question. Is when we were solving for this,
Yeah.
why did we flip the sign, like the inequality sign? Like this is what your answer, the red one. I just didn't understand why we
Can you
flipped
go
it.
back to the question?
Yeah.
If you don't mind, can I write down something here? Explain here, okay? So, so we want to solve this, okay? I know this is one way to do it, but my way is fast, efficient, and accurate. What I do for this, I look at I know the coefficient of x squared greater than 0 concave up, and then I identify the roots, what make this equal to 0. One is -4, the other is +3. You are completely correct, by the way, because that will take a longer process. My way, identify 2 roots. Quadratic equation, you have 2 roots, right? And then look at it, oh, greater 0. This curve, you tell me which part is greater 0. This part greater 0 because it is above x. Maybe y is somewhere here. Okay? This part is greater than 0. So I directly go solution by looking at this diagram. This number will make this greater 0, and all the number here will make this greater 0. Final answer here, union with 3. This is final answer here and here. Those x will make this greater 0. And your way is completely correct. You say, okay, 2 items greater 0, this greater 0, this greater 0, or both smaller than 0. This is your way. But you miss this one. If both negative times negative still make it is positive. So you have to consider two situations. If doing your way, you have to do this. It will take a longer process.
Okay.
So use my way. You found equal 0, found 2 points, -4, 3. Then you look at this diagram. Oh, which part is greater 0? This part and this part will make it greater 0.
Okay.
And if I change the question to this smaller 0, the answer is this part will make this graph smaller 0 because it is below x-axis.
Oh, okay. Perfect. I can just copy that down.
Yeah, sure.
Or take
Yeah.
your phone. Want to take a picture of it? After. Thank you so much.
You're welcome. Thanks for asking. Yeah. Hi, Cameron. Hi, Emily.
Okay. For this one, why do we have to do? I thought the domain was only the denominator.
Oh, the domain is all the x make each component of original function work. It is
Okay.
not just denominator.
It's all of it.
It is all of
Okay.
the whole package.
So that's why x had to be greater than or equal to 1.
Correct.
Okay. So that's, and then, so we just could get rid of this because we knew it had to be greater than 1, so it couldn't have been less than 1.
Right.
Okay. What if this was just like a polynomial? Would
You
did
don't
X just, then it wouldn't matter?
Yeah, doesn't matter. If this is x squared plus 1, doesn't matter because
Okay.
x could be any number.
Okay.
But this is square root.
Right.
Anything inside square root must be greater or equal to 0.
Right. Okay. So if this was just a regular polynomial on top, then it wouldn't matter.
No,
Okay. It's just
Doesn't
because
matter.
it's the
square
square
root.
root.
Yeah,
Okay, that makes
correct.
more sense. And then you also said there is 2 textbook questions we should do.
Thank you.
Could I write this down?
Sure. Okay, this is page number. Example 6 and example 7 on page 145. That is about average rate of change, instantaneous rate of change.
It's okay. Sorry.
Sorry, it's okay.
I didn't get it too.
Thank you.
Good night.
Okay. So 6 and 7, page 145. Thank you very much.
You're welcome. Thanks for your
You're
question.
welcome. So if we do the review and those 2 textbook questions, we should be good for the test.
And you
on
have
Friday.
to reach a level that without thinking, you know how to do it. Do it again, again, and again. The same question again and again and again.
From the review?
Yeah,
Okay.
from the review, again, again, again. And then do some extra questions from examples, similar questions. Those 10 questions are important.
Okay.
Yeah.
Thank you.
You're welcome. Good night. Yes.
So those are the questions that we should do on top of the extra.
Yeah, I forgot to mention those 2 examples in
Okay.
the textbook,
Okay.
145, yeah.
I'll look at
About
those.
average rate of change, instantaneous rate of change.
And then for the last question, could I just take a picture of the
Absolutely, yeah, sure,
Because I could.
sure, no
I
problem.
just missed
Yeah.
the last one.
Yeah. Which one? This is the last question.
I was
Question
at
24. I'm
So,
not sure which slide.
I'm at the last line, I think. So x2, right there. Can I just make sure? Do you?
Absolutely, yes,
Thanks. 2 minus 1 2 and y over that 2 root
Take your time.
I think it was. I just had to make sure because I ran out of room on the one page, so I had to put a new page in, and then that's where I got lost. I was like, I can't remember where I was. X minus 4y over x y. Thank you.
You're welcome.
I think I got it.
Mr. Anderson. Good luck on test 1.
Thank you.
It's very
And
hard. Okay?
I will, yeah, and it's not on section 4.1 and 2, right? Or it is?
Up to 3.6.
Up to 3.6.
Up
Okay.
to 3.6.
I remembered you saying, I just wanted to make sure. I was like, I feel like I remember her saying no 4, but I wanted to make sure.
Great.
Thank you.
You're welcome. Good night.
Thank you.
You're welcome. You too. Yeah.
Sorry.